This is a series of examples for the worksheet for Module 5 in the Sims 1 lab called Slope, Plot, Area 1. The first set of problems ask you to find the slope of the following points. Now remember, in order to find the slope, you have to follow a specific formula. The formula for finding slope is when you take the difference of the two y values and put them over the difference of the two x values. Remember, in your coordinate pair, they always go xy, xy, alphabetical order. So to find the slope, I want to take the two y values, which for number 1 are 9 and 5, and I'm going to do 9 minus 5, over my next two values are 5 and 2, so 5 minus 2. 9 minus 5 is 4. 5 minus 2 is 3. 4/3 does not reduce into another nice fraction, and I want to keep it as rise over run, so I will keep it as the fraction 4 over 3. Now you do the rest of problems 2 through 7. Alright, now we're going to practice plotting points. And the funny thing is, a lot of you have been plotting them backward. What I want you to remember is that the first number is your x value, and it tells you whether you should go left or right. Your second number is your y value, and it tells you whether you should go up or down. So let's look at the first point, 1, 3. We're going to need to go right 1 and up 3. The next point is -4, -2. That means we're going to need to go left 4 and down 2. The third point we're going to plot is 4, 1. That means we're going to go to the right and up. Then we have -3, 3. We're going to go left and up. Then we have 4, -3. We're going to go right and down. And finally we're going to plot the point 1, 3. We're going to go right and up. Now before we can plot these points, we need to decide where our axes should be, which means we need to know how far up and down we need to go, how far left and right we need to go, so we can figure out where our origin should be. I like to work with my x values first. I have a 1, -4, 4, -3, 4, and 1. The smallest x value is -4. The largest x value is +4. So I need to be able to go from -4 to +4, going from left to right. Well, that's a difference of 8. There are 1, 2, 3, 4, 5, 6, 7, 8, 9 places on this particular grid. So we're going to have to be careful. It looks like we'll need our y-axis to be pretty much in the middle. Now, on my y values, I have a 3, -2, 1, 3, -3, and 3. So the highest we'll need to go is 3, and the lowest we'll need to go is -3. That's a distance of 6 places. And again, this is 9 by 9. So pretty much it looks like if we put our axes in the middle of this grid, it should work. Use a ruler. Don't freehand it. Okay, so there we go with some axes. Let's start plotting the points. 1, 3, I need to go right 1 and up 3. -4, -2, I need to go left 4, 1, 2, 3, 4, and down 1, 2. Now I want to connect them in order. 4, 1 to the right, 4, up 1. I'm going to connect it to that last point. -3, 3, left 3, up 3. Connect it to the previous point. 4, -3, over 4, up 3. Oh, no, 4, -3, sorry, over 4, down 3. And 1, 3, we're going back to our original point, And it looks like we have made a star. Now before you begin to do this grid on your own, I want you to remember the things that we talked about. The first number is your x value. It tells you whether you should go to the left or to the right. Your second number is your y value. If it's positive, you go up, and if it's negative, you go down. You need to connect the points in order. Be careful. Remember, I almost made a mistake. Make sure you go the right direction. If you need to, put the arrows by the numbers like I did over here. Also notice, I did not tell you where your axes should be or where your origin should be. You're going to need to do the same thing I did, where you look at your highest and lowest x value, your highest and lowest y value, and think logically about where you should draw your axes before you ever even begin to plot your points. Good luck with this. Look at this triangle. I know it's not a regular shape because I told you on this side it's 4 inches and that on this side it's 5 inches. In order to be a regular shape, all 3 sides would have to be the same length. What I want you to practice here is your area formula for a triangle. Now remember, some of us learned it one way and some of us learned it another. Many of us learned that area is equal to 1/2 times the base times the height. Others of us learned to do base times height and then divide by 2. Remember, these are the exact same formulas. It's just a matter of how you incorporate the 1/2. Do you like to multiply by 1/2 or do you prefer to divide by 2? Now looking at the way this picture is oriented, the 4 inches here represents my height. The 5 inches here represents my base value. So according to this formula, which I've noticed a lot of you like to use, I'm going to do 5 times 4, and then I'm going to take that answer and divide by 2. What is 5 times 4? That's right, it's 20. But I still need to divide by 2. 20 divided by 2 is 10. Now we're doing area, so I'm going to come up here to my answer line and I'm going to put down the 10, but now I need to look at my units. I was measuring in inches, so I'm going to put inches, and because it's area, it's inches squared. Please make sure that you remember the proper label. Area is always, in whatever the units are, squared. You try number 11. Alright, now we're going to practice finding the area of irregular shapes. If you notice, I gave you a set of prompts over here that will help you find the total area of your irregular shape. The first thing we want to do is find out how many are completely filled in boxes, meaning that when I look at this irregular shape that I've drawn, I'm going to come through and I'm going to color all of the grid squares that are completely inside of this irregular shape. Alright, when I looked, I decided that the corner of this one was cut off, and that's why I have not colored it in. The corner of this one down here was cut off. This one was obviously cut in half. This one lost a corner, this one lost a corner, cut in half, lost a corner, lost this whole edge. This looked like it was entirely contained, and this one to me looked like it was entirely contained, but cut off, contained, cut in half, cut in half. This one met nicely at the corner, and all of these are cut in half. That's why I chose the ones that I did to color in completely. Now, let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I colored in 16 of those grids completely. So over here where it says completely filled in boxes, I'm going to write 16. Now, partially filled in boxes. What I mean is, let's go back and using a different color, let's color in all the boxes that have part of the shape. Alright, so what I did was I followed the outline of my irregular shape, and any box that that black line traveled through, I colored in a different color. And now what we're going to do is go around and count how many of those partially filled in boxes we have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26. So it looks like there are 26 of them. So I'm going to come over here and write down that I have 26 of those, what I'm thinking of as partially filled boxes. Well, on average, half the boxes are filled with the irregular shape, and half the boxes lie outside the irregular shape. So if we divide by 2, then approximately 13 more full grid squares would be filled in. The last thing I want to do now is use this information to find the total area of the irregular shape. So what we're going to do is we're going to work with the 16 completely filled in boxes and the 13 partially filled in boxes and ask ourselves, what is 16 plus 13? It's 29. And because this is area, our units are squared. Now I want you to try the same process on problem number 13.